Hi folks, we're going to talk about highlights from week 3, and this week we talked about multiple regression and in particular standard multiple regression. So we're going to talk about 3 things in this highlights video. We're going to talk about research questions, particularly for standard multiple regression. We're going to talk about the basic steps of how to approach the analysis and the basic steps of interpreting results. So, some possible research questions for standard multiple regression. One example, how well is our dependent variable, grade achieved on the final exam, predicted using all or a subset of the following independent variables? And you see them all listed there. That's from our Elliott and Woodward text, page 149. Another way to word a research question for standard multiple regression, we could word it as, which combination of independent variables, in this case risk-taking behaviors, best predicts the amount of suicide behavior, which is our continuous dependent variable, among adolescents? And that's from Chapter 2, Mertler and Van Atta, in our course binder. Another way of wording a research question for standard multiple regression, we could ask it as, what best predicts our dependent variable, in this case self-esteem, from among the following independent variables? And here we're looking at personality variables, including negative affect, positive affect, openness, extroversion, eroticism, and trait anxiety. And that's from our textbook, Chapter 5b, Myers et al. So in Myers et al., they do a really nice job of explaining on page 160 the goals or how to think about writing a research question for standard multiple regression. So you can do all or some of these things that are listed here. So we use standard regression when we want to predict one variable, one dependent variable, from a combination of other independent variables. We might use it when we wanted to determine which independent variables are better predictors than others. We would use standard regression when we want to examine the relationship of one independent variable in the presence of all the other independent variables. And we might also use standard regression when we want to statistically explain the variance of one variable using a set of other independent variables. And again, in standard regression, all IVs are entered at once and remain in the analysis. Okay, so now let's move on to how to approach the analysis. And first, let's look at data prep. We talked about this last week in week 2, and it's discussed in the week 2 highlights. So we'll just do a brief overview here. We're always going to do data cleaning. We're going to get to know our data by looking at the frequencies and examining minimum and maximum values, means, standard deviations, seeing how our sample did on the variables that we've included in our analysis. We're also going to see if there's anything unusual about the data or anything that needs to be fixed in terms of incorrect values, although again that's less common now that we do mostly online surveys. Then we're going to do data screening, and in data screening we're examining missing values. Again, we went through that quite a lot last week, so I'm not going to reiterate all that here. We're also going to check for univariate outliers, and we have several ways to do that. We're going to check for multivariate outliers, which just means looking at outliers when all of your IVs are considered together. Univariate outliers are when we're looking at outliers among our variables one at a time. We're also going to run descriptives again to get to know our data, and we're going to look at several things listed here to get to know the basic distribution of our data. Are there outliers? What are the scores, etc.? And all of this again is discussed in the cheat sheet for Chapter 3A and 3B in Myers et al. In your course binders. So data cleaning, data screening, and then next we're going to check for assumptions, and we're going to check for 2 types of assumptions. First are methodological assumptions. First, are the observations independent? Is the sample representative? So independent observation simply means that is one case not more or less related to another. So an example where we don't have independent observations would be if we had 2 classrooms with 2 different teachers, and we got data from both of the students in both of those classes, if I'm in one class, my data is going to be more highly related to the other students in my class. So we would need to do a different type of analysis. So that's an example of nested data. So with multiple regression, we don't want nested data. We want the data so that each case is not more or less associated with other cases. And so we want the data to be independent and the sample to be representative as much as possible. We also want to consider the appropriate level of measurement of our IVs and our DV. Our DV must be continuous, and there's only one for multiple regression. For our IVs, they can be either categorical or continuous, so quantitative is continuous. If they're categorical and they have 3 or more categories, then we have to dummy code them, and we'll talk about that in week 4. We also want to be sure we have an appropriate sample size. So one convention that's used is to do a quick computation of 50 plus 8 times the number of actual independent variables to see if the ratio of cases to variables is okay for your sample. So let's say we have 4 independent variables. 8 times 4 is 32. 32 plus 50 is 82, so we would want to have a sample size of at least 82 in order to have a big enough ratio of cases to variables, or we can do a power analysis in G-Power, and there is an example handout on Canvas for multiple regression. For our statistical assumptions, some of these we're going to run before we run our analyses, and others are included in the analyses. And again, we talked about these last week, and you have a highlight video on it. But just to touch on it, we're going to look at normality of the independent variables on the dependent variable, and we're going to look at that a couple of different ways. Univariate normality just means one variable at a time. Multivariate normality is more difficult to assess. And typically we just accept multivariate normality if we have univariate normality across our IVs and our DV. There are more advanced ways to check for multivariate normality that we don't typically address in this class, but they're out there. We're also going to look at normality of residuals. That's really important. There are several tests that we looked at here that are all talked about in last week's material and touched on in last week's video. The next statistical assumption is linearity of our IVs, each of our IVs that are quantitative with the dependent variable, and we look at scatter plots and Pearson correlations to assess for that. We will also want equal variance or homoscedasticity of all of our independent variables on our dependent variable, and there's a particular plot that we look at for that, and that's also in our annotated output for week 3. We're also going to check for multicollinearity of our IVs as a group, and we have 2 statistics, tolerance and variance inflation factors, that we look at that come out in our analysis, and we have cutoffs that we can check that make that very easy to check. And then finally, how do we approach our analysis after we check our assumptions? We run our actual analysis, and again, that may include some of our statistical assumptions. And there are syntax files that have been provided for you for your data analysis assignment, where all you do is fill in your variable names. And also, as we do this each week, you've also got syntax files where you can see how to run the analysis and how to fill in those variables, so that it's pretty straightforward. In terms of the results, we're going to look at 3 things. Basically, is our model significant? We look at our ANOVA table for that. Is the p-value for the F statistic less than 0.05? If it is, our model as a whole, all of our IVs together, are significant. How much variance is explained? We check the adjusted R-squared for that, and we have a percentage of the variance in the dependent variable that is explained by the group of independent variables. And then finally, we look at which variables contribute the most or least to prediction and what's learned from that. And we check 3 different things, or we compute a couple of those. So one thing we check is our standardized betas, and we're looking at how far are those coefficients from 0. 0 means no prediction. Closer to 1 or -1 means stronger prediction. We also compute our squared semi-partial correlations from the semi-partial correlations, and those are called part in the SPSS output just to make it a little bit confusing. But basically, we also can multiply this by 100 and get a percentage of prediction of the percentage that that particular variable uniquely predicts the dependent variable apart from all of the other variables in the model. We also compute our structure coefficients, which tells us how highly correlated each variable is to the predicted dependent variable. Higher is better. And again, for each of these, the higher the coefficient is, the closer it is to 1 or -1, the stronger the prediction of each of the variables. Okay, one last thing we're going to talk about is how to approach in terms of how to approach the analysis, is effect size of the overall regression analysis. And this is pretty easy to compute. It's talked about on page 156, 157 of Elliott and Woodward. And we compute the F-squared statistic. This is an effect size measure for multiple regression. So it tells us the magnitude of the effect. And the effect size of the model is small if the F-squared is less than 0.15. If it's medium, if it's 0.15 and less than 0.35, and it's large if it's 0.35 or greater. So that's very easy to compute, and that tells us the magnitude or strength of our overall model. So for your learning, 2 or 3 times this semester, or hopefully at least once, reread chapters 4A and 5A of your textbook, Myers et al. You'll get more and more each time you do. Review the frequently asked questions for multiple regression and the annotated output for week 3 in your course binders. And also the Elliott and Woodward chapters, really good, chapter 5. They do it a little bit more succinctly than Myers et al. They cover correlation, simple linear regression, and regression in chapter 5. So I would highly recommend reviewing that. And then also review your data analysis assignment handouts. That goes through everything in a very step-by-step fashion. You're going to find that each time you review these materials, you're going to learn more and more. You can do this. Your data analysis assignment, if you do multiple regression, will help you learn it. And again, for your dissertation, multiple regression is a really doable analysis. So I hope you have fun reviewing all the materials. As always, let me know if you have any questions, and thank you so much for your attention.